Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 12, Browser Security Headers. Alice, this is the alphabet soup episode. Core, CSRF, CSP, HSTS. Why should a legal tech developer care about HTTP headers, the metadata instructions that travel alongside every web request and response?
Because your application runs in your user's browser, and the browser will do incredibly dangerous things unless you explicitly tell it not to. By default, it'll execute JavaScript from any origin, send credentials to any domain, let your app be embedded in iframes on malicious pages, and connect over plain HTTP if asked. Security headers are your instructions to the browser. Here's what's permitted, everything else is blocked.
Right, let's start with cores. I see developers wrestling with this constantly, usually by setting access control below our origin to start and calling it done.
Which is exactly the wrong answer. Course, cross-origin resource sharing, controls which external websites can make requests to your API and read the responses. The browser's same origin policy blocks cross-origin reads by default. CoreS selectively relaxes that. When you set allow origin to star, you're saying any website on the internet can read responses from your API.
And for legal SaaS specifically.
If your document API reflects any origin header back in access control allowed origin and includes allow credentials, true. An attacker's website can silently read your user's privileged case files while they have an active session open in another tab. The lawyer visits a malicious link, maybe something that looked like a court notice. And in the background, JavaScript on that page is pulling their client's merger documents through your API using their existing session cookie.
The fix being, only allow origins you explicitly trust.
Maintain a strict allow list. Validate the incoming origin header against that list. Only echo back exact matches. And never use regex patterns that can be tricked. Something like anything ending in lawfirm.com will match evillawfirm.com too.
Okay, next. CSRF. Cross-site request forgery. How is that different from chorus issues?
Chorus is about reading responses. CSRF is about triggering actions. The attack. A user visits a malicious page while logged into your application. That page contains a hidden form that submits to your API. Maybe post to API matter share with an attacker-controlled email. The browser automatically attaches the user's session cookie, the small token that keeps you logged in, as we discussed in episode 6, because it's a same-site request from the browser's perspective. Your server sees a valid authenticated request and executes it.
So the attacker never steals credentials. They just use the user's existing session.
Exactly. For legal tech, the actions available through CSRF are devastating. Share a privileged case file with an external party. Grant document access. Approve a trust account transfer. Change notification settings so alerts go to an attacker-controlled email. All performed with the lawyer's own authenticated session.
Defenses.
3 layers. First, same-site cookies. Set your session cookie to same-site lax at minimum, which blocks cookies on cross-site post requests. Modern browsers default to lax, but be explicit. Second, CSRF tokens. Generate a random token per session. Include it in every form and AJAX request. AJAX being the technique JavaScript uses to send requests to the server in the background without reloading the page. Validate server-side. The attacker's page can't read this token because of the same origin policy, the browser rule we mentioned in episode 9 that prevents one website from reading another website's data. Third, validate the origin or referrer header on all state-changing requests.
CSP next. Content security policy. I know this one has a reputation for being hard to deploy.
It is the single most effective defense against XSS, cross-site scripting, which we covered in depth in episode 9. CSP tells the browser exactly which sources of content are allowed. If an attacker injects a script tag through an XSS vulnerability, but your CSP says only execute scripts from my own domain with a specific nonce, the injected script simply doesn't run. The browser blocks it.
Yeah, what does a good CSP look like for a legal SaaS app?
Start with default to singular self. Nothing loads from external sources unless explicitly permitted. Script to singular self with a per request nonce. No inline scripts without the nonce. No eval. Frame answers none. Your app can't be embedded in iframes. Form action self. Forms can only submit to your own origin. This blocks both XSS payload execution and clickjacking in one header.
You mentioned it's hard to deploy. Why?
Because most applications have inline scripts, third-party analytics, CDN-loaded libraries. CDN being a content delivery network, a service that hosts files on servers around the world for faster loading, and embedded widgets that a strict CSP will break. The solution: start with content security policy report only. Same syntax, but violations get reported instead of blocked. Collect reports for a few weeks. Identify legitimate sources. Add them to your allow list. Then switch to enforcement mode. Iterate. Don't deploy blind.
What about X-frame options and HSTS?
X-frame options. Deny prevents your app from being embedded in iframes. Without it, an attacker overlays a transparent iframe of your application over a decoy page. The user thinks they're clicking download cat photo, but they're actually clicking share case file in your invisible iframe. That's clickjacking, tricking users into clicking something they can't see. For legal SaaS, there's almost never a legitimate reason to allow external framing.
And HSTS.
HTTP strict transport security tells the browser to only connect over HTTPS, never HTTP. Without it, a man in the middle on the network can downgrade the connection and intercept everything. Set max age to at least 1 year, include subdomains, and submit to the HSTS preload list so enforcement starts on the very first visit, before any header is received.
These headers feel like they should be set and forget. Are they?
They should be, but they drift. A developer adds a new third-party integration and weakens the CSP. Someone removes HSTS during debugging and forgets to restore it. A new subdomain launches without headers configured. The solution: scan in CI/CD, your continuous integration and continuous deployment pipeline, the automated system that builds, tests, and deploys your code. Mozilla Observatory and SecurityHeaders.com both provide automated grading. A deployment that removes a security header should fail the pipeline.
Right. The mental model here is defense in depth.
Precisely. No single header stops all attacks. CSP catches XSS that input sanitization missed. Same-site cookies catch CSRF that missing tokens would allow. HTS catches TLS downgrades, where an attacker forces the connection back to unencrypted HTTP, sometimes called SSL stripping. That certificate configuration alone can't prevent. Each layer covers gaps in the others. For legal SaaS, where a single compromise session exposes attorney-client privilege, you want every layer active.
Next episode, TLS and HTTPS from scratch, certificates, cipher suites, and the decisions hiding behind just add HTTPS.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.